I'm Shimela Ariasaf, and this is the paper that I reviewed. The title of the project was Sentiment Analysis of Customer Product Review using Machine Learning. And the keywords that were in this paper, we have big data, text classification, text mining, machine learning, and sentiment analysis. Sorry for the spelling. To the next slide. The problem that is being solved in this paper was poor decision making and lack of product insights by customers. Actually, this paper is all about creating a model, a classifier that's gonna classify given reviews into positive or negative. And after classifying them, it will be able to display or provide them to the customers. Therefore, it will allow a customer in a way that the customer will be able to view a certain sentiment as positive, and therefore will be able to make a better judgment, because if a review is positive about a product or a phone, remember this, their project is focused on mobile phones, on a product mobile phones, and therefore when a customer finds out that the particular brand has a positive feedback, therefore this customer will make a better judgment by buying that product and will not regret in the future. And it actually uses over 400,000 reviews to be classified as positive and negative to be used for sentiment analysis. Moving to the next slide. The machine learning models used in this paper were three. We have the naive Bayes, which is a statistical classifier that maps input features to the output class labels. Then we have the support vector machine, and this one uses labeled data and categorizes it into testing using optimal hyperparameters or hyperplanes. We have a decision tree, and this one is a hierarchical tree structure that encompasses decisions by representing attributes and edges for denoting attribute values. Moving to the next slide. On the next slide, we have the model used for evaluation, and this model was the cross validation, and the real model that they used was the K cross validation. And the cross validation is where a model or parameters that demonstrate the ability of the system to make new predictions accurately. And the random sample of 300 reviews will be taken for training and testing the dataset in three classifiers. As you've seen, the classifiers, there's the naive Bayes, the support vector machine, and the decision trees. Now the K-fold cross validation will be implemented, and it will determine the efficiency of the model. The dataset will be divided into K subsets, which is repeated K times, and for iteration of K will be used on a training sample and K-1 on the testing sample, and the three models will be cross-validated 10 times to get the results and to get the accurate one. And that is the results after the three models have been cross-validated. The strengths and weaknesses of those models, we have the naive Bayes. We start with the strength. We have the naive Bayes, and it says that it is simple. Meaning that it requires minimal computational resources for training and prediction. Then we have that it is robust to irrelevant features, like as the assumption of feature independence allows the model to focus on relevant information. We have the support vector machine, And the support vector machine is effective in high dimensional spaces, like it makes them suitable for datasets with many values. It is robust to overfitting, especially in those high dimensional spaces when using appropriate regularization parameters. We can say it can handle nonlinear decision boundaries, meaning when we use kernel functions to map data into dimensional spaces, it can do that. It can handle nonlinear decision boundaries. Then the decision trees, they are easy to interpret and visualize. And this makes them suitable for explaining model decisions to stakeholders or clients. We have It captures complex interactions between features and target variables. And this makes them flexible for various types of datasets. When we go to the weaknesses, we start with the naive bias, and it has a strong assumption of feature independence and may not hold true for all datasets. It is sensitivity, and it may produce outliers, and its limited expressiveness compared to other models. Then we go to support vector machine. Its complexity, it is complex in terms of computing. Let's say, like, if a dataset is huge, is big or large, in terms of computing, it may become difficult for the programmer to compute the results. And then it's less interpretable compared to the decision trees. Then when we talk about the weaknesses of the decision tree, we have it is prone to overfitting. Then, and also it lacks robustness to changes in the dataset. Let's say it can't hold when the data change. There is a change in the dataset. Slide. We talk about the strength and weaknesses of the evaluation matrix, the cross-validation. Like, it provides a robust estimate of the model performance by averaging performance metrics over multiple iterations. Then it reduces bias and variance in performance. Because of time, I will just read them briefly. And talking about the weaknesses, it can be computationally expensive, and it may lead to variability in performance estimates depending on the choice of K. Also, it does not account for data distribution shifts, like it may affect reliability of performance estimates in certain contexts. Thank you. I remain Chimera Ariasov. Bye.